Continue on to 3.1. It's calculating electric potential or voltage due to point charges. So continue reading in Untitled Chapter 18. If you're doing OpenStax, then please do Chapter 7 in University of Physics OpenStax. All right. If you haven't started on the sapling homework, please do so now. This tutorial or this lecture is going to help you out a lot. All right. So here we go. Calculation of electric potential due to point charges. So again, voltage, how we got voltage is we integrated the electric field with respect to distance. This is the electric field of a point charge, which is kq divided by r squared. We integrated that and you get kq divided by r. Another interpretation, if you have a capacitor and you know the electric field, just multiply that by the distance and then you have the voltage. So again, to recap, last problem is that voltages are heights. Okay, they can be interpreted as a height. A positive voltage creates a mountain. A negative voltage will create a trough. And here we go. Let's go ahead and play around with the equation. And the base equation that we're going to be using here. Oops, I got to go ahead and go to comments. I'm going to have to mark this up. So I'm going to close this. We're going to be using, let's try using the text box a little bit here. All right. So what I'm going to do is create a text box in each one of these. We're going to use a text box, and we're going to be using that to write our equations. Okay. What I'm going to do is I'm going to really quickly, Z, just write the equation for the voltage equation at the top here. And voltage is equal to kq divided by r. Remember, there's no absolute value. Okay. So we've seen this done before. We've had to do this test before, but we're doing it with electric field lines. Now we're doing it with interpretations and quantifications of creating an equation for the electric field. Well, now we're going to do it for voltage. Okay. So you're going to be using, you're going to be creating an equation to interpret the voltage at A, so the voltage at this point right here, in terms of K, Q, and R. Okay, and in this case, it literally will be KQ divided by R. All right, so you have a charge Q. It's going to be creating a voltage at this point, so it would be kind of a rounded equipotential line to reflect the surface perpendicular to the electric field line. But this is a height off the ground, so we don't have to draw arrows or any of that stuff. So basically, this, to interpret what the voltage is at A at this point right here, we have K is our constant, Q, and divided by R. Okay, the distance apart. And this is distance r away. So that's how you do the voltage at A. Go ahead and try creating an equation in terms of K, Q, and R for the voltage at this point, which is going to be the voltage at B. So go ahead and pause the video and try that now. All right. Well, in this case, we have two Q's built up on this source. And we're going to try to detect the voltage over here, which is a distance 2r away. So K times 2q divided by 2r away. So I'm going to bring the 2's in front, 2 divided by 2, and bring the letters or variables to the back. 2 divided by 2. So those things are going to just go to 1. And this is also going to be kq over r. Interesting. So let's move on to the next one. Let's do this one. Try to find the voltage at C at this point right here. So go ahead and pause the video and try this one out. Okay. All right. This source is also 2q, so it's k times 2q divided by, it's a distance r away. So again, like this earlier one, I'm going to move the numbers in front, so that is k2q, so that's going to be 2kq over r. So this voltage here is twice the voltage of either one of those. Interesting. Let's try the next one, D. Well, you have a source, Q. So here we're trying to find the voltage at this point right here. And its source is only a Q, so that's only KQ. And it's a distance 2R away. So the 2R is going to be on the bottom. So just like the other ones, I'm going to move the numbers to the front, which is going to be 1/2 KQ divided by R. So there we go. We've made little equations for each one of these cases. Let's try the next problem. And this one has got a little bit more of a quantification type of problem. Here, what do you do when you have two charges? All right. Well, in this problem right here, you have a positive Q sitting at the 0 point. So this is going to be 0 meters. So 0 meters right here. 0 meters. And there's a point 1/3 away. They're not exactly lined up. I apologize. And you have a negative 2Q over here. So what do you do to calculate the voltage at this point, which is right here at X? So you have a positive Q here, and you have a negative 2Q here. So we've got to calculate the voltage at this point right here. Okay, well, what you do is you sum the voltages, all right? So you have a voltage, you're going to sum the voltage at position X, right there. Let's take the positive Q. The positive Q is a distance 0.3 meters away from this point right here. So I'm going to call that KQ divided by 0.3 meters away. And that is a positive Q causing that one. The negative Q, the negative 2Q, is a distance, it looks like this is going to be 1/3 a meter in between these 2 points, and this is going to be 2/3 of a meter, or 0.66. But this is going to be adding a K and a negative Q, which is going to create a negative voltage. And this is a distance 0.67 meters away. Okay, so basically you sum the voltages. You have two overlapping voltages. You have a positive voltage here, and you have a negative voltage over here. And notice that the voltage is going to be just below. It's going to be somewhere in the negative area at that X, all right, due to this graph. So that means this is going to be a larger number, and I'm sorry, that should have been a negative 2Q there. So this is going to be a negative voltage, which is going to be greater than this, and this overall is going to become a negative. Okay? Well, we're going to practice this in this next group of problems, all right? So this is one of your worksheets. This is one of your lecture tutorials that I want you to try. So Mark Summers created these wonderful lecture tutorials, and I love them. And we're going to use them to do our active learning. Well, the lecture tutorial, the practice one called Electric Potentials, it's 2.13, and I believe I attached it as one of it. We're going to do the problem over here. We're going to do a problem that's a lot like your problems that you have to do in the lecture tutorial. All right. So in here, Mark says that this distance right here, 2 blocks, is a distance D. All right. And what we're going to be doing is evaluating the voltages at each one of these points. The voltage at A, the voltage at B, the voltage at C, the voltage at D, and the voltage at E. Now we have a positive 3Q right here, and we have a negative Q right here. So we're going to be, let's take a look at this and think about this for a second, right? If this was a negative Q here, I'm going to just make some guesses as to what the voltages are going to be as far as very negative or just somewhat negative, or zero voltage or positive voltage or a very positive voltage, right? So we're looking down on a mountainside, and this is a really high mountain, 3 times higher. And this is underwater. So this is a trough, one height down. And this below sea level, below 0 volts. And this is 3 times higher above sea level or above 0 volts, right? Well, if this was a negative Q and this were just a positive 1Q and this is a negative 1Q, the center would be 0 voltage. But since this is such a high mountain, it's going to push 0 voltage probably to be closer to B. So I'm predicting that B is going to be 0 volts. This is going to be a positive voltage. This is going to be a somewhat higher voltage, and this is going to be a very high voltage. I'm thinking that A is going to be a negative voltage. All right. So I'm predicting that A is going to be a negative voltage. I'm predicting that Z is going to be a 0 voltage. C is going to be a positive voltage, D is going to be an even higher positive voltage, and E is going to be an even higher positive voltage than D. Okay? Well, let's see if that works out. Let's go ahead and do the first one together. All right, so A has 2 overlapping voltages on it. It has a voltage, a negative voltage right here due to this negative Q. It's going to also have a positive voltage on top of it from this positive 3Q way down over here. Okay. Well, let's go ahead and calculate. So you're going to be always summing up your voltages. And let's do the voltage due to charge 1 first. So we're going to have the voltage due to the first one, and we're going to add that due to the voltage due to this, the positive 3Q. In fact, I'll just call this negative Q. And voltage due to the negative Q, and we're going to add that to the voltage due to the positive 2 or 3Q rather. So we're going to adding those voltage. This is going to end up working to be a negative number, but we're going to let the Q's determine that. So this negative Q is a distance D away. Okay. So it's going to be K times a negative Q all over a distance D away. All right, that's the first one. So that's voltage due to the negative Q. The voltage due to the positive 3Q, well, this is a distance D. This is a distance D. This is a distance D. And this is a distance D. So this 3Q guy is a distance 1, 2, 3, 4, 5 Ds away. So this is going to be K due to a positive 3Q over 5D away. All right. And this is good enough for me, but let's go ahead and reduce this down. I'm going to bring the negative to the front and the numbers to the front and the positives, the numbers to the front and the variables to the back. So what we'll have here is negative 1 KQ all over D. And this is going to be positive 3/5 KQ all over a distance D. So I'm going to factor out a KQ. So this is going to work out to be KQ over distance D. And I'm going to factor, so I'll have a negative 1 plus 3/5 So that's what's 3/5 minus 1. So that is going to be negative 2/5 kq over d. So it is a negative number. Go ahead and try voltage at B. Let's try doing the voltage at B. So pause the video right now and do the steps I just did and try it for yourself. All right. Voltage at B, again, we're going to start off with the negative Q at B plus the voltage due to the positive 3Q. So we're going to be doing the same thing that we just did. The voltage, so we're doing the voltage right here at this point. So the negative Q is creating our voltage. And it's a distance d away from point B. And we're going to add to that the positive voltage created by the positive 3Q, which this is going to be K plus 3Q over 1, 2, 3 Ds away. Again, I'm going to bring the numbers to the front, the letters to the back. This is going to work out to be a negative KQ over D again, plus 3 over 3 KQ over D. 3 over 3 is going to work out. It's going to go to 1. So this is going to be negative 1 KQ over D plus positive 1 KQ over D, which is going to work out to be 0 volts. I was right. Okay, let's move on to the next problem. All right, so the voltage at C. Let's try the voltage at C. Go ahead and pause the video and let's have you guys do that now. All right, let's try voltage at C. So again, we're going to do the voltage due to the negative Q charge and add that to the voltage due to the positive 3Q charge. I'm going to do the same procedure. All right. So it looks like the negative, so this can be K and a negative Q charge. That looks like it is 2 Ds away from point C. And the positive 3Q charge is also a distance 2D away from that. Okay. Again, numbers to the front, letters to the back. Negative 1/2 KQ over D plus 3/2 KQ over D. So that is going to work out to be positive 1 KQ over D. So the voltage here is going to be, the voltage at C is going to be just a positive KQ over D. And this is the voltage at B. And this is the voltage, negative 2/5 KQ over D is a voltage at A. All right, voltage at D. Let's try this one. Go ahead and pause the video and let's see you try it. You use the same method, just be consistent in what you do, and we'll see you try it. Okay. Hit pause now. And we're back. Again, I'm going to do the voltage due to the negative Q, and then add that to the voltage due to the positive 3Q. All right. So the negative Q in this case is, unless it's not a negative 3Q, it's just a negative Q. Negative Q. And it looks like D is 1, 2, 3 D's away. So point capital D is 3 D's away from the negative Q. The positive 3Q is only 1 D away. Again, numbers to the front, letters to the back. So this is going to be negative 1/3 KQ over D. And I'm going to add to that 3 KQs over D. So 3 minus 1/3 is going to be 2 2/3 KQs over D, positive. Okay, 2 2/3 KQ over D. All right, let's try the last one, E. So let's try it. Go ahead and hit pause, and let's see you do the last one. Again, I'm going to follow the same thing and interpret. So I'm going to do the negative V, V due to the negative Q right here. So the negative Q is way up here, and it's a distance 1, 2, 3, 4, 5 D's away from point E. So this is going to be K negative Q over 5D. And the positive 3Q is again only a distance D away. And this is just D away. And so let's see what we get. This is going to be negative 1/5 KQ over D. And just like above, it's going to be 3 KQ over D. And so what we get is positive 2 and 2, 4, positive 2 and 4/5. Okay, because 3 minus 1/5 is 2 and 4/5 KQ over D. Didn't give myself enough room on this. So that is this first worksheet. So I hope you had a good time on this. We're going to go and move on to the next worksheet. But let's move on to the next problem. So let's use actual numbers this time. All right. So this is a situation where you have you want to find the voltage at this point right here. Okay. And this voltage, this is a distance 4 centimeters away, which is 0.04 meters away. Make sure to convert centimeters to meters. And this is a distance 0.03 meters away. Okay. So we're going to notice that this is just along the y-axis. It's going to be really easy to do this. But this positive 2 nanocoulombs charge is off axis. So what do you do in this case? Well, you have to get the straight line distance in between the two. So in this case, this guy is going to be a straight line distance between here. This guy is going to be this is a straight line distance, and we already know that distance. We don't know this distance, but we do know this distance, 0.04 meters, and this is 0.03 meters. So we have to calculate this straight line distance. Well, that is going to be a distance, we're going to call it distance r, and we're going to, and so c squared equals a squared plus b squared. So that's going to be 0.04 meters, and we're going to square that, plus 0.03 meters squared. So I'm just applying Pythagorean's theorem to get the straight line distance from the positive 2 nanocoulomb to this guy, to the voltage point. And we already know this distance is 0.04 meters. Okay. Well, now we could actually do the problem. So we're going to go ahead and do the voltage due to the positive 2 nanocoulomb charge. And then we're going to add to that the voltage due to the negative 1 nanocoulomb charge. All right. Well, how do we do it? Well, the positive 2 nanocoulomb charge, we're going to do that. That's going to be K times 2 times, I should put a positive here, times 10 to the negative 9th coulombs divided by this distance right here, which we have determined is the square root. It's going to be the square root of 0.04 meters, and we're going to square that, plus 0.03 meters. We're going to square that. So that's the voltage due to the positive 2 nanocoulomb charge. The voltage, we're going to add to that the voltage due to the negative 1 nanocoulomb charge. Well, that is K times negative 1 times 10 to the negative 9th coulombs over 0.04 meters away. Okay. Again, I just want to remind you that K is going to be 8.99 times 10 to the 9th newtons per Newton meter squared per coulomb squared. Okay. So just in case you might have forgotten that over spring break, it's been a long time. So there you go. Multiplying this out, what you would find out is that is about 135 volts. By the way, you could have just done this as a 3, 4, 5 right triangle. I did it the hard way. So that'll be 5 centimeters or 0.05 meters. Okay. And so, again, there is no electric field lines that you have to draw. You don't have to do any of that. This is closer to the negative charge, but the positive charge is twice that. So this is going to end up working to be just positive by 135 volts. Okay. All right. Well, let's practice that. Let's do this similar thing that we did up in here in this worksheet, but we're going to do that for the electric potential worksheet that we have for Mark. We're going to calculate the voltage at A and compare that to the voltage at D. So we're only going to do 2 of these. All right. We've done the voltage at B. We could similar type of task to get the voltage at B, and I'm going to just do that real quick. This is a distance D away. This is a distance D. Oops. This is a distance D right here. Distance D. This is a distance D. So I'm going to get the voltage at B really quick. That's going to be K due to the negative 5Q, right? You have a negative 5Q, a distance D away. And you're going to add that to the K due to the positive 4Q. That is a distance 1. So this is a distance D2. So 1, 2, 3 Ds away. Right? So that would be negative 5KQ over D plus 4/3 KQ over D. And that's going to work out to be, what is it, negative 3 and 2/3 KQ over D, I believe. I might have made a mistake there. 5 minus 1 1/3, so that's 4, and then it would be 3 2/3. Yeah, that looks about right. Right. The voltage at C, Again, you're going to have two overlapping voltages on at C. The negative 5Q is going to be now a distance 1, 2, 3 Ds away from C. The 4Q, the positive 4Q is going to be a distance 1 D away. It's supposed to be a positive. Negative 5/3 KQ over D. And this is going to be positive 4Q, positive 4 KQ over D. So that's how you do this one. But I want to get to A. A is a really fun one to do because just like the last problem, which right here, we're going to have to employ Pythagorean's theorem. Okay, so A is a distance D plus D plus D away from the negative 5Q. So that is a distance of 3 Ds away from the negative 5Q. It's a distance, so we could do that really easily, and let's do that really quickly. Whoops, we're going to be doing the voltage at A. So the voltage at A due to the negative 5Q. So the negative 5Q, so that's K times negative 5Q all over a distance of 3D. Well, now we have to get the distance from A to the positive 4Q to get the other one. So that's K plus 4Q. And that is, well, we don't know. That's 3D, and this is going to be 1, 2, 3, 4 Ds away. So this is a distance 4 Ds away. And so this distance right here is going to be, again, it's going to be R squared, C squared equals A squared plus B squared. So that's going to be 3D that we're squaring plus 4D that we're going to be squaring, square root. And what that's going to work out to be is that R is going to be equal to 5D. So this is going to be 5D away. And I just, again, did Pythagorean's theorem. All right. Numbers to the front, letters to the back. Negative 5/3 KQ over D plus 4/5 KQ over D. We're going to reduce this down. So this is going to be negative 2/3 plus 4/5. Good Lord. I don't want to do that. Anyways, this is acceptable to me. Okay. So we'll just, these ones, let's just keep it in these forms to keep it simple and interpretable. Let's see you try D. Let's see you do D yourself. And let's see you try that. All right, so you're going to have to do this distance to the negative 5Q is to the point D, and this distance to the positive 4Q to point D. Let's see you try that. Go ahead and pause the video and try it yourself. All right, here we go. Let's do the distance from D to the negative 5Q. So that's going to be K times negative 5Q to get that voltage there. And that is going to be, well, we already figured it out. It's 4D over 3D. So that's going to be 5D. Plus K due to the positive 4Q. And that is a distance 3D away. So, oops, 3D away. So numbers to the front, letters to the back. This is going to be 5 divided by 5. So that'll be negative 5 divided by 5. That'll be a negative KQ divided by D. plus 4 divided by 3 KQ divided by D. All right. There you go. Homework-related questions. Please attempt this problem in 5.04 in Physics 131 or 4.09 in Physics 112. This next problem is a really good one to try. 405 in 4.05 and 5.06. And 4.03 in Physics 112. If you're in 131, this is 5.07. And finally, 4.08 in Physics 112 and 5.09 in Physics 131. So these are all really good problems that couple with two-dimensional, how do you calculate things that are off-axis, voltages that are off-axis. All right, good luck.